Well, hello, everyone. Welcome to this fine Tuesday, this wonderful training Tuesday. We are going to be talking about the Symons Soldier Beam System today. My name is Heidi Reese, and I am the Dayton Superior and Symons Training Program Manager. And I'm sitting here with Chuck Hoke. We're super excited to talk about one of our systems on the Symons side this week. Just want to go over a couple of items like usual prior to getting started. Everyone that is called in has been muted so that the webinar can be free of other disruptions on the line, no dogs barking, as much as I love dogs. But we can all hear the same thing, and hopefully it will be a wonderfully pleasant experience. But I don't want that to stop you from asking any questions that you might have or any comments. So you can do that through the chat functionality in the Zoom program itself. Just go ahead and you can send it to everyone or just me, Heidi Reese, and we can get those questions answered for you. And at the end of the presentation, we'll have a mini question and answer so that we can definitely handle the questions at that time. If we run out of time, never fear, we will stay on, or you can send them to me later and we will get them answered for you. So in addition, each of our webinars are recorded and placed on the Dayton Superior YouTube channel, as well as DaytonSuperior.com website. Just search for Training Tuesday. You'll find two links, one to register and the other one for all of the past presentations. So today we're going to be learning more about the Symons Soldier Beam system. It's quite a versatile system. Its unique design makes these construction beams adaptable to almost any forming configuration. And like I said, here to tell us more about the system is Chuck Hoke, our National Training Manager. Before he gets started, I want to tell you a little bit about Chuck. For 49 years, Chuck has been in and around the construction industry, working 20 of those as an accessory, forming, and/or chemical dealer. Following that fantastic lineup, he then came to Dayton Superior, and 30 years ago now, he has been in various roles such as product manager for different products and different projects as well. And now, like I said, he is our National Training Manager. Chuck truly understands the ins and outs of our business and is such a great asset to all of us as a subject matter expert for the concrete construction industry. So let's welcome Chuck and teach us about the great system here.
And good afternoon, everybody, and thank you, Heidi, for that introduction. This presentation, as always, is intended for training purposes only. For technical specifications, any of the products mentioned here within this presentation, you can refer back to DaytonSuperior.com or contact your Dayton Superior sales representative. So let's get going here. Today we're going to talk about the Symons Soldier System. The Soldier System is an accessory system that typically goes along with any of these Symons manufactured forming systems. It has a multitude of different uses and capabilities. The system itself can be used in platform forming, shoring, bracing, etc. It's all steel construction beam service, high strength to weight ratio, which basically means you're getting a very high strength capacity brace and support system with minimal weight of steel. And it is compatible with all Symons forming systems, including everything from STEEL-PLY, Sym-PLY, FlexForm, Maxiform STS, the backbone system, etc. So this system here is extremely versatile and is also used in conjunction with the Spaceless system, which will be the next week's Training Tuesday here. With that being said, the system here, and it's a fully 100% rentable system. Typically, you're looking at 50 KSI steel. It has a unique hole pattern which allows it to be bolted up to any of the systems that we mentioned earlier. Extra heavy duty end plates, so that these pieces here can be butt together, bolted, and you will maintain structural strength throughout that joint. It is compatible with all Symons STEEL-PLY systems, as we mentioned earlier, and it is an alternative to Versaform ladlers. The Versaform ladlers are typically a heavy-duty 8-inch heavy steel channel Versaform ladler. This system here offers you a little bit heavier unit, but also a much stronger unit, also ladler in particular. Benefits include on this, it's very cost effective, lightweight, it's high strength, it can be bolted to any flange or web within our system. It has the full moment when it's bolted end to end, once again, maintaining that structural strength throughout the splice joint. The system compatibility. The compatibility is it works in conjunction with everything that we mentioned, from STEEL-PLY to SYM-PLY to FlexForm to SDS, and also space-lift system. It can be a component of, or it can be a standalone component also. It's extremely versatile. I say a lot of times people look at this system here, and then I kind of date myself. As a kid, we all had erector sets as kids growing up, where we could bolt pieces together to build different construction projects, or et cetera. This is a very similar product to that system. It's stronger than a 5-inch ladler, but it is lighter than an 8-inch ladler. So you're getting additional strength without the weight. Now this system here, as we talk, is a 9-inch square box beam. And as you can see, it runs 9 inches, has multiple holes on the sides. Typically, it's available from 1.5 feet, 2 foot, 3 foot, 4 foot, 8 foot, and 12-foot lengths. And you can then take any of these component pieces, bolt them together to get the desired length that you're looking for. Once these pieces are bolted together, they bolt together end to end. They can also you can bolt any of these component pieces onto the side, whether it be perpendicular as an intersection or as a secondary support. This system here is extremely flexible in allowing you to join the pieces together depending on what you're looking for. Some of the things that you see Maxiform being used for, elevated platforms. You can basically shore elevated platforms going up. This is a Maxiform project that was done down in Texas here, and you can see they're actually pouring concrete on this system here, and you can see that's probably a good, I'm going to say probably a good 45 feet in the air. The system actually helped build basically what we would call a dance floor to allow the forms to be set up, and then the concrete to be poured in place. It worked in conjunction with Maxiform, and as you can see, the system itself here is extremely soft, strong, and durable. Here is just a quick layout of your rendering of that system, how it actually bolted up in place. You can see how the various pieces were put in place. You put some cross braces in and around it to actually help support the system prior to attachment of the maxiform up on top of it. This system, once again, is extremely versatile and capable to be pretty much manipulated to do whatever you really need for it to do. Bracing, heavy-duty bracing. When bracing is out of the question with a standard pipe brace, obviously Maxiform Maxiform can bend, STS can be braced with the soldier system. You can see extremely tall columns here being used on a bridge project right next to the ramps system. So basically, rigidity and strength is a necessity. So this system here, actually, we adapted so that we could brace from two sides to actually hold it in place. So we got no movement from within the columns from one load, etc. And the bracing system with the soldier beam is a lot stronger than you would typically see with a system, either a AccuBrace system, which is a helical ground anchor system, or a pipe brace system in general. Here's another photograph of it. You can see the location of the rail tracks. So it was imperative that we actually made sure that those forms would not move on, before, or during the concrete pour. Once the concrete pour was taking place and the concrete had cured, we removed the form and we actually rebraced the concrete just to reiterate the strength of until the concrete came up to full strength, being that it was right next to the Amtrak line. Here you can see a large platform, large wall structure going in place here using STEEL-PLY. The soldier system was an excellent product for that STEEL-PLY system. The STEEL-PLY system enabled you to set your details and everything else. With this system, you've got 1,000 pounds per square foot. Your bracing can now be done with the soldier beam to hold up so you don't have any turnbuckles, etc. And basically, you can use the soldier beam as a large turnbuckle, as there is some adjustability on the end screws that actually hold the plates, angle plates, onto the soldier beam itself. One of the big pluses with this system is using it as a one-sided wall form system. And this system here was predominantly used with STEEL-PLY on a lot of projects here, a lot of bridge projects, just primarily because of setting these projects in where we could not get anything overhead to carry additional supporting in. So we had to basically hand set pretty much most of this system in place. So here you can see we are using a Symons STEEL-PLY system, using the soldier beam as a strong back system on it, and also using it, the soldier as your backbone system for back bracing back to, once again, your anchor plate on the ground is a soldier beam. So you're making a connection there, making that soldier beam a one-sided wall form support system. And that one-sided support system is then anchored into the ground at the front face of it and in the back end of it, so that, and you have full adjustability with the system up and down, and this enables you to actually set the camber of the wall, etc. You can also see we've done what we would call tubs. concrete tubs in the system here. We can do double-sided tubs where we're coming in and along the side and casting the concrete up multiple stories high at the time. And what it is they'll be doing one-sided wall form system here, and the whole system is shored from the left to the right and right to left, allowing you to actually pour the concrete at a high rate of speed based off of what forming system you're typically using. Here it looks like they are using a Maxiform, so they're pouring it somewhere around 10, 12 feet an hour, 15 feet an hour. And basically this system here is supporting the system from both sides simultaneously. Once again, here's a better look of the one-sided wall form system. Once again, using STEEL-PLY as your main forming system. And you're coming in and you've got adjustability within that coil rod, within the diagonal piece here. You've got considerable adjustability, so if you have to make an adjustability as far as pitch or camber, you can actually just turn the turnbuckle left to right to basically make that adjustability before you reconnect it to the anchor plate. So we have the one-sided one-sided bracket typically is used in this type of an application. It's a component piece that actually is designed to marry up to the soldier. This actually connects the vertical piece with the horizontal base piece, and it allows you to have a slot that you can then attach an anchor into the ground. So whether it be a threaded anchor in the ground or a double coil or whatever, this gives you that ability to actually anchor the system at that point easily and conveniently. We've also got pivot brackets that actually help set those angles. So you can see we actually put pivot brackets on both ends, making it extremely easy to set a 45-degree angle in conjunction with any of these component pieces that need to have not so much a 90-degree connection, but anything up between 180 degrees you can actually make with this system. Strut jack, typically we put this strut jack in place. This is actually going on the base form system. And what it is this enables you to connect to the bottom of the soldier beam or to the side. And what it enables you to do is level or true the soldier beam depending on the application of it. Sometimes you'll see these being used on the bottom as a screw jack to primarily help set the camber of the form. And the adjustability on this is extremely simple and easy to do. With this, a large coil nut there on the top and bottom, you can basically just set this in place and turn the nut and washer plate until you get the desired support that you're looking for underneath that soldier beam. The short jack is another component piece. Jack provides 8 inches of adjustability, basically for a reshore application. If you're looking at reshoring on your floor and let's say you're doing a high rise or whatever, and you need to reshore, you can actually set this in place, set the soldier on top of it, run the soldier up to the top of the pink concrete that was just poured, either connect to another soldier running parallel with the floor slab, or another forming system or some other mechanism in place. Because of the bolt hole configuration with soldier, you can easily do that. And this actually helps enable you to actually set this, especially in a high shoring position, do your reshore and then just keep moving. Because of the high strength with the soldier, you can use fewer pieces than a typical pipe brace type shore. We also have the adapter spacer. Basically, you bolt it in for the swivel wheel or traveling applications. You'll see in some other photos that we have here where we've done some traveling, and we can actually bolt the system in with a wheeled system underneath it to actually help move the form system along. And typically we would do that in like a traveling box culvert, etc. We have a 45-degree back bracket. It has a fixed 45-degree bracket, so you can come off of this with a strut coming off of it straight at a 45-degree to connect into your soldier beam, so you can help set that 45-degree angle or the diagonal component piece of that support system. Other items that we've got a washer plate available. Basically, with having a slotted, it gives you little slotted anchor slots there. You've got a little bit more adjustability. We have a lap splice plate if you need additional strength when you're running from beam to beam, especially in the truss type application. And we also have a jack bracket, which typically would get bolted to the side of the soldier beam, and this would actually enable you to help set the camber or reset those if you don't have a jack at the end. You can set a jack in the middle of the form, closer to where your pivot points are going to be for that form. Here you can see you got a strut jack being put in place here with a leveling jack bracket. This enables you to, as your pressure is all going to be located right into that location of the soldier beam. So by putting the leveling jack in place, the leveling jack bracket at that location with the strut jack, you can now jack that up and basically give you a strong bearing surface right at that point. You have a one-sided wall bracket right in place here. That helps with the connection to the vertical and the horizontal peak members. And you have a pivot bracket, as you can see up here on the top. Actually helps keep that nice and at a 45 relatively clean. Here you can see the anchor assembly going in place here. Here we have a slab on the bottom that we cast earlier, and we've located inserts in that to actually accept a threaded coil bolt product. Typically you're seeing these as 1.25 inch and a half to up to about 2 inch in diameter. So you're seeing some fairly large anchor bolts being put in place here for this system. Now, when you're doing a stadium, looking at stair risers are one of those things that are a pain in the butt for a lot of contractors to have to deal with. You've got riser brackets you got to deal with and riser frames. They're constantly changing depending on the scope of the work around the stadium, based off of what the run and rise is of each step. Typically, the rise is similar, but that the run happens to alter depending on location within the stadium. So this system basically lets you set a platform at the bottom of the formed area and one at the top of the formed area, and basically set so you can put your incremental run and rise in, basically suspend it from the top of this down through, with your formwork in place. And then this component piece can then be hoisted as one piece and relocated to a section right next to it. It can be moved around the stadium wherever the contractor wishes to have it go. As you can see, some of the rise boards going in place, the risers coming in here. You don't have any additional formwork being put in place. Everything, all the formwork and support is all being constructed from overhead. You have basically a support down at the bottom and a support up at the top, and then this is a self-spanning system. It spans from one end, on the bottom of the formed area, to the other end of the form area with no supports in between. We also have here a traveling box system. This is a box culvert frame. Typically, you can see this, it can be a single-sided, it can be a three-sided system. A lot of times you'll see this where they will come back in and they'll pour the sidewalls. Once the sidewalls are poured, then they'll come back and pour the top or the top surface up here, whether it's over a roadway, highway, etc. They will come back in, set this up so that the system has been poured. They will build basically a table out of soldier beam. Set it close to the elevations that they need. You'll have your boards, basically your rollers on the bottom, whether they be wheels or actually true rollers. It will come in place. You can basically come in and set your jacks down, jack it up and up to set your elevation. When you're done, you come in, you drop the elevation back down, your jacks down. Once it hits the rollers, you slide the whole unit ahead, reset it back up again. So this is like an extremely high production run area. Very much similar to slip forming, only with the form system actually being set up in place, cleaned as once you move it along, and then poured against again. Now, resources that are available on this. There is an ID chart available, and you will find technical data sheets. All of this is available on our website, www.daytonsuperior.com. In the search criteria, type in the word soldier, and what'll come up with is a drop-down box with all of the different categories and all the different components. They have a technical data sheet, the ID chart, the brochures, and any other technical information that you're looking for. Now, if you're looking for training resources, if you are requiring additional training, please scan the QR code here off to the right. That will actually get a hold of Heidi Reese or myself.
That's me.
And at that point, we can set up a training for you. If you want to just look at all additional other trainings that are available, please feel free to go to DaytonSuperior.com, or you can go to YouTube and actually call it Dayton Superior, and the Dayton Superior channel on YouTube will come up with all of these presentations that we've done for Training Tuesday. Feel free to approach and watch those as many or as often as you'd like. And if you do have any questions or are looking for additional information as far as training goes, please contact either Heidi Reese or myself at DaytonSuperior.com.
That's right, Chuck. They can go ahead and go on to training at DaytonSuperior.com. That'll email both of us if you have any other training needs. We are almost to the limit, so I'm going to thank you guys for joining us today. And remember that we have these every Tuesday on different topics. Chuck did mention that we have the space lift coming up for next Tuesday, so stay tuned for that. If you have any questions, please go ahead and you can ask them or send them to training@daytonsuperior.com and we will get them answered for you. But for now, I hope all of you have a great Tuesday, and I'll email you later and let you know when this is online. Thanks, everyone.